Good morning, everybody. Thank you very much for turning up to what is going to be the last LinkedIn User Groups event for 2012. This is our 9th and final event in the LIDNUG Wintellect series, and we're going to have Walt Richer. He's going to be presenting supercharging your XAML with pixel shaders and custom HLSL. Just a quick one about Walt. Walt is an MVP, he's an author, he's a trainer, and he's also a Wintellect consultant. And I quickly want to thank our sponsors, Ortrip, Telerate, Pluralsight, and also still Syncfusion for all of their support. Without your guys' support, we simply just wouldn't be able to do what we're doing for our members. So thank you very much, and thank you for your support through 2012. So in 2013, what's next? Yes, we have the guy with the red polo coming up in January. We also have another series with Wintellect being planned, and we have planned and put up the first of a series with Redgate. So there's plenty of high quality presentations coming back in 2013. Good housekeeping. Any questions to us or any comments, feel free to email us at info@lidnug.org. You can also catch us on Twitter, Facebook, both with /LIDNUG. All of our events are also being recorded, and we upload them to our LIDNUG channel on YouTube, and feel free to go up and have a look at them and spread them around. Also our website, www.lidnug.org or bit.ly/LIDNUG. It's currently undergoing some changes, and we will hopefully soon have a new website available to people. And tonight's MC is Brian Hitz-Matson, that's me. And before I hand over to Walt, then from all of us at LIDNUG, I want to wish you a safe, happy, and joyful holiday seasons. Thank you for your support in 2012. Walt, thank you very much for taking time out this close to the Christmas holidays to come and present for us. We truly do appreciate that.
Well, you're welcome. I love talking about this technology. I love it so much I wrote a book about it.
Yes.
So, thank you for inviting me.
You're most welcome.
See if I can get my desktop to share. There we go. So this is going to be an interesting experiment. I am teaching off of an old laptop that with Windows 7 on it to make it work happy with the current version of Live Meeting that we're using. So some of the software that I usually have installed in my computer is not available, like the DirectX SDK. As was mentioned earlier, my name is Walt Richer. Let's see if I can move this to another window. Do you know how to move this window here?
See, is that one there, yeah?
Yeah, okay. So my name is Walt Richer. You can contact me at my Wintellect email address, waltr@wintellect.com, if you have questions after the seminar. I'm also on Twitter. I just use my first and last name at the Twitter website. My blog is mostly about XAML technology, and you can find it at xamlwonderland.com. I am speaking to you today from the U.S. I'm up in Washington State in the upper left-hand corner. I happen to live in the city of Seattle. And today, in my time, it's about 10 a.m. in the morning. Beautiful pre-winter day here. I think Brian mentioned that I do some writing. I've got a number of articles in Code Magazine. The technologies that I work with are listed here, ASP.NET MVC, all the XAML technologies, Windows Phone, Windows 8, WPF and Silverlight. Today's course we're going to be talking about, today's talk we're going to be talking about the XAML side, and everything I show you today was applicable to either WPF or Silverlight. not the new Windows 8 SDK. If you're doing like Windows Store applications, you can't use the Pixel Shader API that I'm going to show you in the Windows RT side. You have to use DirectX instead. I also have an HLSL book out there, HLSL and Pixel Shaders for XAML developers. I saw it this morning. It's on sale in the U.S. anyway, for the Kindle version, $2 off the normal price. So you want to grab a copy right now before moving on. I work with a company called Wintellect, as you may have heard. We're a Microsoft Gold certified partner, and we do a lot of very interesting things in the software world, including training. We have about 30 classes that we offer, and we have a large consulting department, and we also specialize in debugging. And so you have a nasty debugging problem, we're happy to send one of our Wintellect consultants out and see what's up. We also have some partner offers coming along with this course. There's going to be a drawing at the end of today's course. So everybody that's attending this class, you have a chance of winning a virtual training course. I just taught a virtual training course this week, and one of the attendees was a winner from an earlier class this year. We also have a partnership going with SyncFusion. SyncFusion is going to be giving all the attendees access to their technical resource portal. So if you go to the syncfusion.com tech portal, that'll tell you more about how that works, or ask Brian, or send me an email. I'll get to the right people. I'm also a video author on lynda.com. I have a number of titles there. If you're interested, just head to lynda.com. So I always get asked, when I mention that I wrote a book about shaders, if I'm talking to .NET developers, is, well, what can I do with that? That's interesting, but isn't shaders for games? And the short answer is yes, shaders are very popular in the gaming industry. They were originally invented for the movie industry to make digitally created animations or items, three-dimensional items, like in the old Star Wars movies. So you'd create a model of an item and try to inject that into a movie scene. It didn't look natural because it was a computer-generated object, and so someone wrote a shader algorithm that would take and apply shadows and reflections onto the three-dimensional object so that it would look like it fit into the movie scene. And then it was adopted by the gaming industry, and then later Microsoft created DirectX to work with that, and there's OpenGL and other systems out there. So what do you do in a business application? And so I have a few examples here. This is an example of using a shader in a background situation. So let me show you. I have a live example of this. This is a Visual Studio 2012 project. I have, this is a WPF application. I have two XAML files in here. I have a main window main-window.xaml file, and I also have a message view. So this is like my version of a dialog box. And what we're going to do is we're going to show the dialog box, and it's going to be a modal system, and the dialog is going to take up about 50% of the screen size. So I'm going to maximize my window. If you look at main window here, it's set to be maximized. Window state is maximized. I have placed two buttons on the main window.xaml, both of them that instantiate an instance of my message view. When the message view gets instantiated, it takes up about 50% of the screen with what looks like the UI, but the rest of the screen is a transparent background. And what we're going to do is we're going to apply a pixel shader to the background to blur it and apply a different color. So the code for doing this is quite simple. I'm going to instantiate an instance of my message view, tell it what words to show on the dialog, and then I have an enumerated value here, message icon.info, which picks the colors from my shader. And then down here, you see I'm choosing a different one, message icon.warning. And then the shaders are over here in this message view. I'm programmatically instantiating the shaders in when the dialog is shown. So this is what it looks like when you run the application live. What I did is I created this application. In the background, I have a large image in the background of a picture of a road and a fire burning in the background. When I click on this show message, there comes my simulated dialog. And as you can see in the background, I have a blue overcast. And this is what's called a telescopic zoom. So at the edges of the picture, the blurring is being applied, and it looks like it's kind of pointing towards the center of the screen. Okay. Now, if I'm not sure what it's doing. I would like to stop the application. You see it on my list.
Message view demo.
Is it there? I'm not seeing it.
Yeah, there's two entries.
There it is. Okay, there it is. I found it.
It's easy to spot because one of them always has .vshost.
I'll try this one more time, and I'll click on this one to show message. And this time I'm using a different color on the effect. So this is the warning. There's also an error, which is red colored. And it looks like that's broken as far as not being able to close that application. So good thing I left my task manager open. Okay. All right, next we're going to look at other types of items. Here's an application that uses pixel shaders that were created inside one of my tools called Shazam. This is a portrait pad. It's used by police departments for drawing suspects pictures. So here we're using shaders around the edge of the hair to get the shadows and to do the blending of the different items. So what you do here is you run this application. Go search for portrait pad on your favorite search engine, and then you can put a face in here, pick the glasses, pick the hair, pick the beards and the chins and the ears and everything else. And I believe the pixel shaders here are being used for blending purposes. Blending modes are also used in Photoshop. I don't have Photoshop installed in this machine. I don't have a license for this old laptop, but I do have GIMP installed. So let me show you a quick example of how this would work. So here is a GIMP application. This has two pictures in it that are layered. So I've got a picture of this flower. And I think I need to change my color values. It's looking pretty sketchy here. going to take longer to render, but it looks better. So there's my flower picture, and then on the top layer over top of that, I have this fractal design. And with blending modes, what you do is you use the pixel shader to combine the colors in one of the layers with the colors in the other layers, and then you use the shader algorithms to quickly apply this algorithm. So right now I'm set to normal, but if I go down here and choose the difference blending mode, you can see that the colors from the top picture are being blended with the colors on the bottom picture, and you get a very artistic version of this picture. So that's called the difference mode. Let me just show you one more. Here we'll go down and choose the hue mode. Okay. And close GIMP. There's another application I won't demo live. That's called Nicola.com Easy Painter. This is a painting program that has all sorts of effects, like ripple effects and things like that are done with shaders. Here's another example. Let's say that you want to de-emphasize part of your UI. So here I've got a list of albums on the screen, some of the music, and you want to de-emphasize that while you bring something into the foreground. So here's that same UI with a shader applied that's muting. It's desaturating the colors. And as the last example here, there's different kinds of blurring algorithms you can do with shaders to make things look blurry, of course. I showed you one with my background shader. So one of the things I've seen done is, let's say that you have a list of pictures like this on the screen, and the user can slide them back and forth with the mouse. Okay? So what you can do as you're moving to the left and right, what you do is just as the user grabs it with their mouse or the finger nowadays, and they slide it to the left, you turn on a blur effect. So it looks like this bottom half of the picture. And then as they're moving it, it looks very blurry. It looks like it's moving faster than what they're scrolling. And then when they let go with the mouse, then you turn off the shader. I'm going to be working with Expression Blend and Visual Studio 2012. The Expression Blend version that I'm using is a preview version. Right now, Microsoft in Visual Studio 2012, they've shipped Visual Studio 2012, and they've shipped one version of Expression Blend that only works with what are called the Windows Store applications. Okay? So if you want to do WPF development in Blend or Silverlight or or you want to use the Sketchflow tools, you have to download their preview edition. Now that's free. You can find it on just look for Expression Blend 2012 preview, and you'll find a download copy of that. They're supposed to release this newer version, I believe, at first quarter of next year when they're going to release that. So I'm going to be using that. But what I want to mention is that Blend simplifies adding shaders to your XAML. So you've got a XAML application and you want to put a shader on it. It already has what's called an Effects tab. And inside that Effects tab, they ship with a number of predefined shaders, and plus you can add your own. So what Blend will do is when it detects that you've got a shader class inside your project, it will then add it to this assets pane, and then you can just drag your shader over, or it's called an effect in .NET. You can drag your effect over and drop it on the UI. So let me show you how that's done. So I'm inside Blend. I am opening this main page.xaml again. I believe this is the WPF application I'm working with here. My apologies for the slowness of this. Anytime you do a very graphic and intensive talk like this and you do it over a virtual machine, you're going to suffer the lag of my desktop being, the pixels on my desktop being bundled up and sent to your computer over the internet. All right, so what I've got here is a picture of an eye. I'm going to show you how to create an alien picture. So what I'm going to do is I'm going to take this picture, I'm going to copy it and paste it in. So I'm going to copy it and paste it. So you have two copies over here in my blend objects and timeline. I'm going to drag one of these eyes over and put it next to it. And then I'm going to do a flip. Now, there's a couple ways I can do a flip. One is that I can grab the edge of the eye and drag it over to the other side. So that blend will automatically reverse that eye. And I'm going to drag that in and put them right next to each other like so. Okay. And the next thing I'm going to do is I'm going to go to my Assets pane, and I'm going to go down to the Effects. So here, let's just talk about terminology. In the DirectX world, when you're creating the code that does your effect, that's called a shader. That's written in HLSL. When you bring it into .NET, they're called effects. Okay. So here are some of the effects that they've already created. So I can take this magnify effect and drag it over and drop it on the designer surface. And now what I want you to see is that over here in the objects and timeline, underneath the image is the magnify effect. And it says FX there. And if you don't see this effect, it's disabled by default. Click this button on the bottom of the screen right here. And that will live preview the effects inside Blend. So now I've got this large eye here, and the next thing I want to do is I want to move the center of that eye over a little bit to the right. So I can do that by going over, by clicking on the effect, and in Blend I can go over to the Properties pane, and it's showing me all of the managed properties. So what we're going to learn how to do today is once you write your .NET shader, your .NET effect, it's going to be talking to the unmanaged shader, and you're going to expose public properties on your class. And what's happening here is Blend is picking up those public properties and showing them in the designer. So I can move the center of the eye over a little bit further so I get a nice big round eye. Then I'll do the same thing with the other eye on this side. Move it slightly to the left. And then, of course, if this is supposed to be an alien, I need to change the skin color. Pink's not a good alien skin color. We need something a little more greenish color, right? So there are some different types of effects up here, including one called the color tone. So I'm going to drag this color tone over and drop it on this eye. Well, that didn't quite work the way I expected. It's green, but the bulgy eye disappeared. So what's happening is that there's a rule in .NET that says you can only have one effect applied to any XAML element. So I've got one XAML element, which is my image, and when I tried to put the color tone effect on there, it deleted the bulging effect. So what I can do is wrap this image. I just did an undo, rolled it back. I'm going to do what's called a group into. Another great feature I love inside Blend is I can, it's also in Visual Studio 2012 now, is I can pick the image and then say I want to group that into a canvas. Okay, so now I have a canvas, and inside the canvas is the image. And now what I'm going to do is I'm going to drag the color tone to the canvas. So the color tone is applied to the canvas, and the image has the magnify effect. That's how you can build multiple layers of effects. Right, and then, of course, you can see on the right-hand side of my screen, I've got the dark color and the light color, so I can use this to change the shade of green that I've got applied to that eye. Right, so this is an awesome tool. It lets you preview the effect. That ships with about 15 effects in the system. You'll also notice there's one here called I can find it here. In my project, I have one called Band and Swirl. So this is my C# class. And then I also have this binary file, which is, we're going to learn how to do this in about 10 minutes, how to make these binary files. Those are inside this project. Now, when I compile the project, and go back to the effects pane, you'll see that at the top of the effects pane, there's my custom effect, the banded swirl effect. And it tells you, when I hover over it, you can see it's inside the assembly exploring with blend DLL, where these other ones are inside the Microsoft.expression.media.effects DLL. So that's my effect, and then I should be able to do the same thing, drag that over and drop it on the eye. And because I made it a .NET class and I exposed dependency properties on it, I have my own set of properties over here, so I can change the number of bands on that ripple effect, the aspect ratio, put that back in, the center point of that ripple effect, and how strong it is. So my goal over the next 40 minutes or so is to show you how to write the binary, how do you write the PS file that generates these effects, how to write the .NET class that creates these effects, okay? How to write the dependency properties, how to add them to your project. Really, adding them to your project is quite simple. All you really need to do is go to your project and add this, the managed code and this binary file, and then you need to mark this binary file as a resource for the build option. Right, and then I'm going to show you some third-party tool that makes it really easy to build and test these. So that's my goal over the next 40 minutes or so. Okay, so what is a shader? Shaders are commonly used in 3D rendering systems for doing things like texture blending, lighting of the models, and things like that. There are three kinds of shaders that are popular nowadays. There's what's called a vertex shader, which manipulates a single vertex, which is a point on a triangle mesh in DirectX. So you use this to do things like transforming the shape of a model. So you've got a three-dimensional model, and you want to change the shape programmatically using a shader. That would be what you'd use a vertex shader for. They're also used for lighting at times. Vertex shaders are, pixel shaders can do a lot of the things that vertex shaders used to be able to do. Then we've got geometry shaders, which are adding extra vertices to the input. So if I have a shape that looks like an animal and I want to add some extra points programmatically, I can do that through a geometry shader. So particle generation and fur and shadowing can be done using geometry shaders. And then the third one is a pixel shader. This is the simplest of the three. And what a pixel shader does is it takes one pixel out of a picture and applies an algorithm to it to modify the color of that pixel. So if the color is currently red and I apply a darkening effect, that red color is going to look darker to our eye. When you apply things like a rippling effect, what you're really doing is you're calculating you're taking the color of one pixel in somewhere in the image, and you're moving it 30 pixels to the left. So we're making the picture warp and moving the locations of pixels to what appears to our eye to be another part of the image. And by doing that, it makes the picture look like it's being bent and warped and rippled and so on like that. Now these are combined inside the GPU pipeline. The first thing that always comes first is the vertex shader, then comes the geometry shader, and then the pixel shader. That's always last. Okay. So here's an example of a geometry. This is it's built with some meshes. This is not built with triangle meshes, but it makes the point. It's a sphere. It's got these meshes. So if I'm doing a vertex shader, it's going to take, let's say, this yellow pixel right here and maybe move it a few units to the left or right. So it would distort the shape. The geometry shader would say, let's add some extra vertex points along this line. Okay. The pixel shader says, I see that this is yellow. I want to make one of these pixels in this line orange instead. At this point in the demo, I would normally run a couple of DirectX demos using the DirectX SDK. But on my machine, I'm using this older laptop, I can't install the SDK, so I can't show you any of those. DirectX is the Microsoft's 3D graphics framework. It supports all those shader types I just mentioned. When you work with WPF, XAML, under the covers, it draws the pixels on your screen using something called Direct 3D. So because WPF was built on top of DirectX and not on top of GDI, we have all the benefit of the shader pipeline that's built into DirectX. And so what the WPF team did is figured out a way to expose some of that pipeline to us. They didn't expose the entire pipeline. Right? They only exposed the very end of the pipeline, which is the pixel shader part. Right. There's also XNA. Microsoft has the XNA, which is a way of building 3D applications, usually games, but it's a way of doing shaders with three-dimensional, and it supports vertex shaders too. Okay. Then there's Metro XAML, which is WinRT. I mentioned that already. There is no native support for shaders in that. You have to, at least for the XAML, you can write a DirectX wrapper, and you can call that from your WinRT code, but you can't do any of the techniques I'm going to show you today, like writing a .NET class that wrappers the underlying shader effect. And then Silverlight, those of you who do Silverlight development, the thing about Silverlight is it runs on a virtualized GPU because it runs on cross platforms. It runs on your PCs, it runs on Macs. So what Microsoft did there is they created a virtualized GPU, and your shader runs inside that virtualized GPU, and that way they can figure out how to render it on a PC or on a Mac. Okay. Now, it mimics some portions of DirectX. It is not hardware accelerated like a GPU is. One of the benefits of using the GPU is that it's orders of magnitude faster than doing pixel manipulation or 3D manipulation on your CPU, 10 times faster or more. Okay, and so we don't get that benefit in Silverlight, but it is still faster than other solutions like writable bitmap, and it does use multiple cores. If you're running on a quad-core machine and you're running a Silverlight application, it can use all 4 cores in your computer to calculate the graphic that's going to render. And here's a benchmark that I pulled from Renee Schulte's site on Silverlight 3, but the numbers are about the same in Silverlight 5. If you're using writable bitmap for a test, you can get 19 frames per second. The same test running a pixel shader with 139 frames per second. Right, so that's why we like pixel shaders. They're extremely fast at manipulating the pixels on the screen. Okay. Now, shader effects, there are a large number of shader effects out there. Here's an example of what are called color modification. So I took that picture of the flower I showed you earlier today, and I applied a color modification like a grayscale modification. And there's different algorithms. I'm showing different types of grayscale algorithms here that highlight different color bands inside the original color. But really what this is doing is it's taking all the color out of it and turning it all into equal colors of red, green, and blue. That's what this shader is doing. Here's a color modification that's turning it into black and white. So it's either black or white, no shades of gray. Here is a color modification that uses an input file. So what this is doing, this is kind of like the blend mode I showed you in GIMP a few minutes ago, is I took a black and white photo and I applied a yellow hue to it on this one on the right side of the screen. The one on the left side of the screen was a little more complex. I have like a lookup table of colors. I have a graphic that contains 256 bands of color. Okay? And then we applied a pixel shader that says take one of the bands of the color and apply it to some portion of the picture. So we end up getting this kind of metallic looking image. And this is really cool when you animate this. If I were to animate the banding of that, the bands on the face would move around and it would look like she's made out of metal and there's a spotlight shining on her face and changing direction. Okay. Then we got what I call the distinctive effects, the pixelate effect. That's where you take and make bigger blocks of pixels. So you take the 1 pixel, and the way this algorithm works is you detect, like, you'll move over every 40 pixels. And you'll take the center of the 40 pixels and you'll find out what that color is, and then you'll make that the same color for all 40 pixels that surround that 1 pixel. So what our eye sees is a blocky looking picture. Okay. Old movie effect, we turn it into a monotone color. We darken it. It's darker around the edges than it is in the center of the picture. Right. Parametric edge detection effects. Here we're using an algorithm that finds the edges of color regions and then highlights those. And then here's an interesting one. This is one that was donated to my Shazam project by the community, and this is what's called the sketch effect. So it's trying to make it look like somebody wrote this picture or drew it with a pencil. That's what I'm trying to say. Okay. We got embossing, we got bands drawn on the screen. I love this glass tile effect where it looks like you're looking through a set of glass blocks. And then there's a ripple effect. This is probably the most overused effect you'll see in shader effects is the water drop ripple effect. Here's one. This is called the distortion effect. What I'm doing is taking some of the pixels and I'm altering them based on an algorithm. So in this one, what I'm doing is I'm grabbing some of the pixels on the left side of the source image and copying them and mirroring them over on the right side of the image. Blurs, Gaussian blurs and different kinds of blurring algorithms. Basically, they take the colors and slightly modify the pixels next door to it so that they don't look sharp. There's also one called unsharp mask, which is actually a blurring algorithm that's sometimes used to sharpen up pictures. Here's an example of a transition. At the top left, I have a picture of a flower. And at the bottom left, I have a picture of multiple flowers. And then I'm going to go through a distortion transition. So as I move from one to the other picture, I'm applying this distortion algorithm to take the pictures from one picture and merge them with the other picture, and at the same time distort them on the screen. Now, this is also really easy to do in Blend. Blend has a number of tools for doing progressive transition. I talk a lot about how this works in my book. Okay, next, writing the XAML shader. So there's 2 parts to writing a successful shader. First part is you have to write the unmanaged GPU-specific code. That has to be written in a specific language for whatever framework you pick. So if you're writing in DirectX, then you need one language. If you're writing in OpenGL, you need another language. Okay, and in our case, that's going to be written in a special DirectX dialect called HLSL, which stands for High Level Shader Language. Okay, and you write that code. It looks a lot like C. Okay, you write that code, and then you also have to write a managed .NET wrapper class around it. And that can be written in C# or VB or F#, and then you're going to create a dependency object, and you're going to create dependency properties. Okay. As I said before, a shader is a specialized algorithm. It's designed to run on the GPU. The benefit of the GPU is that it runs the shader code in batches. It'll run it in parallel. So I create one shader program, but it's run thousands of times. And this is where things start changing. If you're used to regular procedural type code or object-oriented code, writing for parallel applications is a completely different mindset. So imagine that you have a picture with, it's 1024 by 768. Right? Every one of those pixels inside that picture will have your shader algorithm applied to it by the GPU. But rather than doing it one at a time, like you're writing a for loop, like for X and for Y coordinates, rather than doing it that way, it takes a batch of pixels. Let's say it takes 240 pixels, and it runs those all in parallel, and it'll apply the algorithm. Then it grabs the next 240 pixels, and it runs the algorithm, and so on. So you can see it can go much faster than going through each pixel one at a time. Now, the deficit for this is that when you're writing your shader algorithm, all your knowledge that you bring into it from working with like a regular picture and thinking of it as a set of X, Y coordinates, they don't work, right? In your HLSL code, you don't have an X and Y coordinate because your algorithm is being run from the perspective of a single pixel, right? You're given a single pixel. So when you write an algorithm that says, I want the color from a pixel, 30 pixels to the left, how are you going to write that code? Okay. Now, shaders. These are the unmanaged portion. Shaders can read from up to 4 sources. They're called textures usually, and that is usually a source image. In our case, when you're working with Silverlight or WPF, that texture is going to be the output from your UI. So if you write the WPF application, what's going to happen is WPF is going to send that over to DirectX. DirectX is going to rasterize it, and then it's going to pass that rasterized image to your shader, and those pixels are going to be what are the inbound source. You can also have what are called numerical inputs. These are called shader contents, shader constants, and those can be floats or combinations of floats. Like I can do 2 floats lumped together. That's called a float 2. And those are passed to shaders via shader constant registers. And each one of these registers has an index, like there's a constant register 1, a constant register 2, and so on. Okay. So how do you create the managed effect class? Well, you have to write that HLSL code. You typically store that in an FX file. You then run the DirectX compiler, which is called fxc.exe. So you run that. You have to install the DirectX SDK to get this file. Now, the DirectX SDK is a 520 megabyte download, and it expands to about 1.2 gigabytes on your hard drive. So for one single file, you have to install 1.2 gigabytes worth of other stuff to do this compilation. Okay? But let's say you have that. You run the fxc.exe, and that turns it into a binary file, which is commonly stored with a PS extension for pixel shader. Okay. Then you create a WPF or Silverlight class that derives from one of Microsoft's classes, which is called the shader effect class. So you would derive off this class here, the shader effect class. And you see there's a couple other built-in effects like blur effect and drop shadow effect that are part of .NET that also drive off this abstract class up here called effect. Okay. And then inside your shader class, you have to write some code to load the shader binary. You have to register your code with the texture registers. You have to create your dependency properties. You have to register your dependency properties with the constant registers, right? And of course, if you're creating these .NET property wrappers, right, you want to create some .NET property wrappers that wrap around your dependency properties. Then you need to compile your WPF class and then add it to your project. And I would probably put it in a DLL and make a separate library out of it. And then you would use your shader class and example our code. And then optionally, you also need to create a testing harness to be able to preview those effects. Okay. Now, that's a lot of work. And it's daunting when you're first learning how to do pixel shaders in XAML code. And so there's a couple of solutions to this. There is a template that works in Visual Studio 2010. I'm not sure if it works in Visual Studio 2012, but you can install it from NuGet and run that. If you're working in the unmanaged code, Visual Studio 2012 also supports a shader tool for building and previewing these, but it doesn't work in managed code. Or you can use a third-party tool. So what I did is a number of years ago is I wrote a tool called Shazam, not to be confused with the music listening software. It's called the Shazam Shader Editor. It's a free tool, and you can get this tool at, I don't think I put the link anywhere in my slides, but it's at Shazam-tool.com. You go to this website, and there's a section on features that tells you what's available and a listing of the sample shaders that come with this application. For instance, there's that banded swirl we saw a few minutes ago. And then if you go to downloads, you can click on the download link I'll send you an email. You'll get an email with an automated link for you to download the copy. Okay, and that's free. Well, I will say we are looking for a sponsor. I'm looking for a sponsor to. I have some premium content that I'd rather not charge the users for, and I'm looking for a sponsor that would step up and back this project. So if you know a company would like to do that, it's a good fit for this, let me know. Okay. So once you get Shazam installed, it does all of the work I just showed you for you. You don't have to have the DirectX SDK installed. No questions there. You don't have to have the DirectX SDK installed. Shazam works.
Sorry, Walt, there's one on the Manage page. If you look on the Manage tab under Q&A.
Oh, here? Yeah, so Andre has a question about the Writable Bitmap EX. Writable Bitmap is an open source project that's a wrapper around Writable Bitmap. And yes, it's very fast. I don't think it's any faster than the native Writable Bitmap, though, because, but I don't know for sure. The person that wrote the benchmarking that I showed you a few minutes ago, he also is one of the developers on that project, so he would know. That's Renee Schulte. He was also the tech editor of my book. How can you check if your WPF app is using DirectX? And that question, do you mean programmatically? If that's the question, I don't know. And that.
Okay, permit me, if you will. I think I know what Andre is asking there.
Yeah.
Programmatically, you can do it using reflection to see whether the DirectX managed assemblies are being linked in, or non-programmatically, you can load your app into something like ILSpy or some other application like Reflector, and it'll list the assemblies that the app's linked against.
Okay. And the other one, that transition gallery, I don't know where that has gone. I would just use my search engine to look for it. It used to be published on Codeplex, I believe. All right, so back to where we're going with this. Let me write one chat room question here. Okay, so this is Shazam. Now, it's a little bit sparse because of the mode that I'm sharing through the virtual meetings. These will look different if you run this on without sharing across a virtual connection, like the buttons across the top. But the way this works is you have a number of images across the top, sample images. And I'm going to go ahead and turn off the shaders for the moment. We'll say remove shaders. So these are the sample pictures that ship with the project, including something called the color wheel. There's a sample WPF UI. You can do things like programmatically select things. There's a media tab, which is playing a video. And then there's a compare tab that you can have your own picture and compare it with it. So let me load a custom picture in here. I'll go up and say File, and then Open Image File. Okay, so there's my custom image, and then over here in the compare, I can see the effect applied to my custom image in the original. And then over here, I've got a UI that shows my folder, so any shaders I've saved on my machine, and I've also got a set of sample shaders. It ships with about 140 sample shaders with all the HLSL code for you. And then it's got a tutorial section which matches all the demos that are inside my book. So if you're using my book, when I say go to example such and such in chapter 4, like here's a I click on this and I see the change color shader applied to it. Okay, and then it also ships, so like I said, about 140 sample shaders. So I can come over here, and the most prevalent ones are the distortion shaders. So I can go in here and take a look at the banded shader. When I look at that, a bigger picture is the banded shader. Here's one for turning it into circles. Here's the embossing and the glass tiles. Okay. Now what Shazam does is it has an editor. So if I go to my view and I say full screen code, this shows you that there's a editor built into my tool that lets you write the HLSL. Okay, so you'd come in here and you write your HLSL down in this section, and then you can go to this tool here and say I want to compile it. So when you run this, it'll run that fxc.exe against your code, turn it into the binary, and then it makes a copy of those files. And at the same time, it also generates the C# or the VB code. So I just generated this C# class, and the name of that's class tiles effect, and it derives off shader effect. And it's written a dependency property, one dependency property for each of my managed, or each of my registers that I have in my HLSL. So this one up here is the dependency property that is registering with .NET that I have a sample. Okay, it's called the register pixel shader sample, or texture, another way of thinking of it. And I placed that in position 0. There's a number of locations I can put that. I put it in position 0 here. And then I created a dependency property I called tiles property, and I'm registering that, and I'm telling it to use the constant register 0, and this is using constant register 1, and this is using constant register 3 in my in the GPU. And here I'm using number 2, and then I have to come down here. And this is the line of code that says I want to register this binary file, class tiles effect PS, with the system. So this is how we're telling .NET to load this into the GPU, and it'll do what is there necessary to load it into the GPU. And what I'm doing here is creating an instance of the .NET class pixel shader, assigning the URI source, assigning that to a property on my type called pixel shader, which is part of the base class. And then I'm calling each one of my properties, input, tiles, bevel, offset, and grout color. I'm registering them once. I'm calling update shader value, which I need to do at least once in my code. And then down here I've got a bunch of wrappers. Here's the .NET wrappers around those dependency properties. Right, so anyway, my tool writes all of that for you, and also does the same thing for VB. So if I go over here to this code and I decide that I want to change one of these registers. See how this has a register of C0? That's one of those constants that's being fed into my effect. Okay. If I want to change this name from tiles to something else, the tiles, compile the shader. Now it has a problem. Now that's another thing that's nice about my tool is I just compiled this and it's got an error. It's because I have a property at the top that I registered called the tiles, but in my code I didn't change it down here. Right. Now you can press F5 just like you do inside Visual Studio to have it compile automatically. And now it's registering. And now if I go over to my generated shader, you'll see that that's now called the tiles property. Okay. Another feature that it has is it has a tryout section. And when you click here, I open up a screen on the bottom that has each one of those dependency properties, and I allow you to modify that in real time. So this is the number of tiles. This is the bevel width. Okay, so there's no bevel width. There's a big bevel width. Here's the offset. And where's the other one? There's the grout color. Right? And so here I can pick the grout color. Okay, that's pretty ugly. And these are all animatable. So what I found was when I was using this a couple of years ago is that I was constantly playing around with the settings, and I got tired of dragging these values around. So what I did is I animated those. You type in the length of the animation here. Let's say I want to do 9 seconds. And then the minimum and maximum value that you want to change, I start with 1 to 20 here. And that information is picked up from the HLSL. I'll show you that in just a few minutes. And then when you click on this animate button, it will just transition between the 0 value and the 20 value over a 9-second time span. So you don't have to keep constantly trying out the sliders. And then you can animate multiple items. Including, you can also animate the color. So I'm going to go from green to black in 3 seconds to do this. Of course, this works for all of them. Look at the banded swirl. Same thing here. I realize that over a virtual connection, it's kind of jerky the way it looks. Because every time it does an animation, it just captures a screen capture and sends it out to your machine. So it's a little bit less. It looks awesome on my machine, I'll just tell you that. Okay, now let's just start with our new one. I'll grab a brand new shader file. Okay, so here's my first demo. Again, I'm pressing F11 right now, which takes me to the full screen view for the code. And then when you press F11, it goes back. And if you press F10, it does F9, I should say. F9 does the full screen of the whatever UI that you currently have up here, right? So the sample UI or the media. And I didn't show you that, but we can automatically apply the shaders to the image, the media, or the sample UI as well. And I'm pressing F9 to switch back and forth between full screen view and the split view like we're doing here. And this is your basic shader. Remember I said this is unmanaged code. This is a special language that was built specifically for DirectX. And the main thing you have to do is you have to have a main method. And when you go to the FXC compiler, you have to tell it what the name of your main method is. Right. So in my case, the Shazam tool assumes that the name of your method is going to be main. Okay. Then there's a special signature you need to do for this. Now you notice I'm double-clicking on these items and I'm getting IntelliSense. So this is telling me more about the float 4, about the text 2D, the TX, that stands for texture, text 2D. Sample function. And the signature of this method has to be, it has to return float 4. Now, the way you think of the float 4 is that's the red, green, blue, and alpha channels for the pixels. So you decide in your algorithm what colors you're going to return for the pixels. So if I return color equal float 0, 0, 0, 1. Oh, I need to say float 4 here. Right. Well, what's happening here is I set this to a dark color, but immediately below this, this is where I did my sampling. This text 2D says, here's the input, and the input is coming from this register up here. I'll talk more about that in a second. Grab the picture, go get one of the pixels, right, and store that current color here. And so what my code's doing right now is it's returning the same color. So really this pixel shader is not doing anything. Okay? But if I were to take this code and put it here, and now build the application, you see I get black because every single pixel was sampled and every single pixel was told to be black. So let's see if I make this one a 1 and compile it. Every pixel's been turned to red. I think you get the idea. So I control what's output from my pixel shader, right? I get to pick the color. And of course, this is really boring what I'm doing here, is what you want to do is you want to say, based on the current color, I want to apply our algorithm that makes sense for that particular color. So if it's at the top of the screen, I want it to be 1. If it's the bottom of the screen, I want it to be 0, right? Something like that. So that would be based on the X and Y position. I said there's no X and Y position, but there's what this gives me is the current pixel. So going back to the rest of this algorithm, let's examine this a little bit more. This represents those textures that are coming into our system. Right? I can have up to 4 of these, or depending on which version of DirectX you're working with. So I've got 1 stored in the register S0, and I can do more of these. But this is the one that you get from WPF facility, okay? Then down here, I can create my constant registers. So I'm going to call this one red value. Okay, and I'm putting that in the register C0, and I'm going to do another one down here. I'll call this one the blue value. And I'm going to, if I try to compile this right now, I should get an error because I'm putting 2 items in the same register. So I'm going to change this one to C1. Again, I get an IntelliSense on all this. It'll tell you things like specify, says I'm calling the register method. Specify, you can't say method, it's a function in HLSL. Calling the register function and specify which constant register to load. So it's also got IntelliSense where it can plug in, if I hit the space bar, it'll plug in the code for me. So now I've registered this one for 1 register and the second one for another register. And then I'm going to come down here and say that this is the red value. And this is the blue. No, not that one. We'll leave that one at 1. And this is the blue value. Press F5 to compile. Okay. And then I go to the Triad tab and set this to 1 and set this to 1. And then when I drag this, I'm changing the red values. When I'm dragging this one, I'm changing the blue values. Yes, now Philip says that you can use SharpDX. SharpDX is one of the tools that you can use in Windows Store applications. And there are several others. I don't remember the names of all of them right now, but SharpDX is one of the more popular ones. You can also use Unity, the big gaming framework. Peter has a question. Can Shazam be automated to produce bin and class files in an MS build script, e.g. for continuous integration and or to build code? Not as at the way it's created right now. It's a standalone desktop application. And so it doesn't have any sort of automation infrastructure built into it. Got a couple chat messages popping up. Oh, and one more question. It was from Andre. Yeah, so I do have a Twitter account. It's waltricher@twitter.com, and also Shazam Tool has a Twitter account too. Okay, so you see what we've done here is I've exposed these constant registers, and then they're being wrapped in the generated code. Again, look what we have here. This is a dependency property called red value property that you see it's of type double. Okay, now how do we pick double? Well, I had to make a decision about that. In the FX file, that's registered as a float. It translates that into a double in the .NET world. Okay. Now there are different kinds of floats. This is another unusual thing about HLSL is that you can have bundles of floats, right? So here is a float 4 that contains 4 float values in a single unit. So it's sort of like an array, right? But it has an interesting syntax. That's what's called a swizzling syntax, which I'll show you in about 5 minutes, which allows me to change those with a unique syntax. Rather than having to use an indexer into the array, I can use a swizzling syntax instead to get to modify the items that are in there. Okay. So when let's see, there's a couple things I want to show you here. Shazam has something that's not part of HLSL, but it's handy if you're trying to test. And like I said, my Shazam tool is used in thousands of .NET shops, and I get emails all the time from game developers who are using it. I had a request about 2 years ago to make it so that when you go to the tryout section, you can set the starting values without having to come here and type a new value. So what we did is some XAML style comments. You put in 3 slashes at and then you've got something called description and default value and a minimum and a maximum. So what you can say here is the minimum value for this red value should be 0. Maximum value for this should be 1. Starting value for this should be 0.3. Now that's a bug in my IntelliSense there. Okay, now I'm going to recompile. And then when I switch back to the tryout tab, you'll see that it starts at 0, goes to 1, and the current slider is set at 0.30. You can also set the default duration of the animation by going to Settings and changing this to a longer value. And for those Silverlight developers in the audience, you're going to want to go in and go to this target framework and choose Silverlight, because the dependency properties and the way the code is written for the dependency object is slightly different for Silverlight. So you want to check Silverlight here, and then it'll use that for generating. If you're running on WPF4 or later, you can use this target, the PS3, Pixel Shaders 3 specification, and then you get more instruction sets. One of the frustrations of HLSL is that if we're using PS2, which is a really old standard, it's about 8 years old, you only get about 128, I think, what's it? 128 instructions, not very many. So what sometimes will happen is you'll be writing your FX over here and you'll run out of instruction slots to put things in, and you'll get an error. Okay, so let's build that again. Switch back to my time. Now you see this section has changed to 9.5. Okay. Okay, so these are my inputs. Again, I can do inputs with different types. So let's do this one. I'll say a float 2 here. And we'll call this one offset. I'm going to store that in register number 2. Okay. Now when I compile that, I don't know if you see it on the bottom of the screen, but there's a tooltip down here. It says right now the shader has not been saved. Okay. And then it says it was last compiled at this time. And then when I do a compile, if you keep your eye on that, there'll be a little slider that'll run across the bottom there that shows you it's doing the compilation. Okay. Now if you look over here, I now have a offset, and I had to make a decision on what that means, right? So what does a float 2 mean? Well, that means it's 2 floats bundled inside a single data type. So it's sort of like a struct, if you want to think of it that way. And what does that translate to on the managed side? So I said that means it's a point. So I turned that into a point class. New point. And then I have this public point offset property down here. But you can influence that by putting these other types in there. So a float2 can be a point, that's the default, but it also can be something called a size or a vector. So what you do is you put a XAML comment in your HLSL, and then my compiler will say, oh, you don't want it to be a point, I'll turn that into a size or a vector. Same thing if you do a float3, that's considered to be a default to be a point 3D, but I can switch it to something called a vector 3D. And the float4 is defaults to a color, but that can also be turned into a point 4D. All right. So then I can use this offset. So let's go back and look at a few more things in my code. Next, let's look at this main method. So the main method is returning a float4, which is my color, and it's taking a float2 in, which you can think of it as the current location. So the shader algorithm, the GPU is running your shader in parallel, and when it's your pixel's turn to be rendered, this method gets called. Remember, this gets called for every single pixel inside your inside the image, and this represents the current location at that float2. Right? And then you have to use what's called a semantic. That's what the text coord and the colors are. Now, the reason why is a float2 could be used to mean multiple things. And remember, we talked about how HLSL, you can string together a vertex shader that feeds into a geometry shader that then feeds into a pixel shader. So as you're passing floats, let's say you build a structure of floats and you're going to pass it from the vertex shader to the pixel shader, right? You have to tell the GPU or DirectX, you have to tell it let's say I have 3 float2s inside my structure that I'm passing over. You have to tell them what float2s have certain meanings. Those are called semantics. So one of the semantics is what's the text coordinate. So you have to put this colon here and then the word text coord. Right? Semantic is a string attached to the shader input or output that conveys information about the intended use of that parameter. Right? And there are always required on variables passed between shader stages. So even though I don't have access to the vertex shaders, and even though I don't have access to the geometry shaders, those are being passed to me from WPF and Silverlight, I still have to write the semantics the correct way. So I have to say this is text coord. And then this semantic means that the float4 that I'm returning is intended to be the color of the pixel. Okay? So now that we know that, I can see how down here I'm using this UV, that's the default name for this variable, in this text coord. So this function returns the value of the texture data, and I'm passing it in a current texture, and then I'm saying get me the XY position for that input, and then this is returning a color value to me. What happens if I do this? This is a float2. This is a float2. I'm adding the offset to this XY position when I do my sample. It's hard to tell because I'm coloring everything. So instead of hard coloring this, maybe I should do a mixture, right? Maybe I should say that I want to take the original color. So what we'll do is we'll take another float 4 here, float 4, and I'm going to call this one current color. It's too opaque. Now I've got some examples of this, so I don't have to keep typing everything, and we only got a few minutes left before we have to call it the end of the day. So if you go to the shader loader and you go to tutorials and you look at getting started, there's a whole section here. What is a shader? The parts of the shader, describe, and have all the comments to describe what I just talked about. Here we talk about colors. Right, and here it talks about variables and parameters, and I'm missing some folders from this. So the ones from my book are not in here. That's curious. I'll have to figure out why that's happening. Well, let's look at the swizzling, because that's interesting, and then we'll look at swapping colors. And so this is a vector. There are groups of the same variable types. This contains a single float. This contains an array type syntax, right? Float array of 2. This uses the vector syntax where I can just say float 2, or int. I want 3 ints combined together, or 4 ints combined together, or 3 floats combined together, and so on. Now to retrieve the item out of a vector, also here's the formal way of doing a vector. I can say the word vector and then the type that I want and the number of items I want to put in there. But this is the shortcut that everybody uses. Okay. And then what I'm doing here is I'm saying go get that color value and retrieve the first item in there using an ordinal position, an indexer, right? But here's this other cool thing called the component namespace. So what I can do is right up here I declared a color. Where did I declare my color? Right here. It's a float 4. So I can use this, what's called a component namespace. So I can say, I would like the red component out of that. So that's going to retrieve the R value that's stored in that float 4. And there's also color B, color G, and color A. Okay. And I can also use the other component namespace where I can say color X, color Y, color Z, and color W. So X and R are equivalent. Y and B are equivalent, Z and G, and so on. Now you can't mix and match. You can't do this, X, G, but you could do X, Y. Okay? And that's the swizzling thing, which is I can access the items all together. So here's a way of working with that color. Right? Here's a float 4, and I'm initializing the values. Okay. Here I'm creating a float 2 that's going to pull 2 of those values out. So I'm saying get the color, first value, and get the green color, and get the blue color. And then this is what's called swizzling. So there's a special syntax where you can combine the 2 of them together, the R and the B, or the R and the G, like that. And what this will do is it'll pull both those values out. In this case, it's stored them in a float 2. Okay. And this is, if I make it RG, and they don't have to be in the order either. I can say RG, BG, RA, and then I would have to make this a float. Let me try compiling this. It should fail. Make that a float 4 to store all those items in there. And there's also, you can do things like this. Let's say you make this a float 3, and then I'll say I want 2 reds in the alpha channel. Right? So the first value in this float 3 will be the red value. The second value in this float 3 will be a red value. And the third value in there will be the alpha value. I have just been informed who our winner is. I know. Oops, I've got an echo on mine. I know who our winner is, and I'm going to announce that in. Am I going to announce it, or Brian? Are you going to announce it? I was going to wait for 5 more minutes before I announce it, but it's trying to build the tension so you know who won the $500 value. No answer. Okay, so you can see swizzling is a very interesting way of dealing with it, for pulling it out. And not only can you pull it out this way, but what if I do this? What if I have this red and blue? Okay. I'm assigning 0.4 and 0.4 to this float too. But with swizzling, I can also do this. So that what will happen is it'll take this 0.4 value and it'll assign it to the first chunk of data, the red channel, and then it'll assign it to the second channel. So this is a way of assigning the same value to both floats. Okay, so let's just take a look at, and we'll swap some colors. I don't want to save the changes. Right, so this picture doesn't look the same anymore. There's the original picture. There's the new picture. So what we're doing here is we're grabbing the color. And then I'm saying, creating this temp float, and then I'm saying store the color B inside here, and then take the color B and assign it to the red channel. Now I'll take the green channel and assign it to the red channel. I'll say color RG equals color blue. So now I'm assigning 2 colors, the red and green channel, to the same color as the blue. So I end up with a grayscale now. Right, then I divided that by 2 and say take whatever the B value is and divide it by 2, and then assign that to both the R and the G value, G channel. And so lots of fun with colors. And then if you do distortion effects, then what you want to do is start changing the colors based on their position. So I'm going to flip this on the vertical axis. What I'm doing here is I'm saying get the UVX value and subtract it from 1. Now that's another thing I forgot to mention, is that everything's normalized to 0 and 1. So when you're thinking about pixels, if this is a 500 by 600 picture, you don't think in terms of 500 position 500. If you want halfway to the picture, you don't have to know it's 250 pixels to be halfway on the X and Y coordinate, and 300 pixels to be halfway up and down in the 600 pixel namespace. Instead, it's normalized to 1 and 0. So if I wanted to change something halfway through the picture, I would do that by assigning it to 0.5. Okay. So what I'm saying here is take 1 and subtract the X value from it, and then assign that to X, and then assign that here, and then I'm changing this inbound value. So now when I do my sampling, I flip the X and Y coordinates. So as you can see, the picture has been reversed. It also works with the sample UI has been flipped backwards. The video will play backwards. Oh, it's hard to tell from this video. But to swap colors, that works. Swapping the colors on the running video. Right. This one's it's called morphing nearby pixels. I just have time for a couple more demos. And so what we're doing here is we're distorting the colors by these mathematical formulas. So I've got a sine, I've got a distort function that I wrote up here that takes 4 floats and returns the square root of some combination of those numbers. So I call my distort function from my main code, and there's a rule in HLSL that says all functions have to be defined above their usage, so I have to put those above my main method. And there's my distort function. I'm passing in the x-coordinate, the y-coordinate, and 2 parameters that I gathered from up here. And I also have a band size parameter. And of course, what that does is allow me to, the banding size is how big or small the wobble is on the picture. Oops. And then this is the center of where the basically it's kind of like a ripple effect that I'm moving around. It's like 2 ripples combined is kind of what I'm doing here, that merge. And again, what you see I'm doing is I'm modifying the XY coordinates before I do my sampling. So this algorithm that I use makes some of the pixels move to the left and some of the pixels move to the right. At least the colors, I'm moving the colors to new positions. I'm sampling a color 3 pixels over and pulling it into the current position. And some of them I move leftward, and some of them I move rightward, and some of them I move up, and some of them I move down, and that makes it look like it's distorted. Now again, I've almost out of time, so just remember this tool is free. It's available on the internet. My book has a chapter on how to use Shazam. My book also contains dozens of examples of HLSL that you can use in your XAML and how to set up your project. I haven't spent a lot of time talking about how to set up your projects, but you remember earlier today I had this project. This is the one with the effect that played in the background. So what I did here is I added that PS file. Oh, and by the way, one more thing I want to show you. If you go to Shazam and you go to Tools and you go to Explore Compiled Shaders, every time you do a build, it makes a folder over here. So like there's that Bands Effects, there's the PS file, and there's the CS file. So you just copy these 2 into your Visual Studio project, like I've done here. So I copied both of those in here. I marked this PS file as a resource. Okay. I made sure that inside my C# class, I reference my namespace. Right here, message view components. That's my DLL or my EXE, right? So make sure you reference that. And then I have to reference whatever folder I placed it in. So I put this PS file in effects, telescopic blur with PS. Now again, Shazam has a tool that can automate this. You can tell it what your namespace is and it'll generate the code automatically for you. Now, I'm just about out of time. So let me announce our winner. The winner of our free virtual course is Philippe Skaken. Philippe Skaken is our winner.
Well, that's great, Walt. Can you hear me okay?
I can hear you.
Yep. Excellent. Congratulations to Philippe. I think we may have lost Brian. He did mutter something about having a few connectivity issues, and even though he looks to be still logged in, he doesn't seem to be responding to anything. So I'll do the wrap up here.
Thank you.
Great presentation. Thank you very, very much for coming along and doing this.
You're welcome.
Certainly a really great presentation to end the year with. Not one for being negative, but it sure as hell beats doing more enterprisey based stuff, that's for sure. Thank you to everybody who's attended this and attended to any of our other presentations throughout the year. We hope to see you all again in 2013, and I do hope that you'll come back in 2013 with some more interesting stuff as well, Walt.
I have many more hours of topics I could talk about. I'd be happy.
Absolutely I'm absolutely sure you do. I'm actually going to go and play with your Shazam tool now because I didn't even know that it existed, and you got me a bit stoked up there, so I'm going to go and have a little bit of fun with it, I think.
Thank you very much.
But for reference, when you were on about the movie theatre bit at the beginning, I don't know if you recall RenderMan.
I do recall RenderMan from Pixar.
Like that. Yep. Well, you can download them free now for Windows.
I did not know that.
They're floating around somewhere. They're quite difficult to find. I believe the free version for the general public is called Blue Moon Render Tools or something like that. And they now come with plugins for things like 3D Studio Max, Blender, and various other 3D kits.
Cool.
So, yeah, it's very nice to look at, and it's also worth mentioning that the current version of 3D Studio Max, in fact every version of 3D Studio Max from version 9 up over, can load those FX files, the HLSL files that you've been demonstrating.
Yes.
You can load them natively directly into the texture editors in 3D Studio Max version 9 upwards, which is quite cool.
Yes. Yeah, I actually have a chapter. The first chapter in my book talks about RenderMan and how the whole pixel shader world came about in the movie industry and how it ended up in our desktop applications, and how Microsoft and Adobe and some other companies helped make that happen.
Oh, it's certainly some fantastic stuff. Some absolutely awesomely fantastic stuff. But once again, thank you, and thanks to everybody who attended.
Thank you. Have a great day, everyone.